All right, this is going to be Unit 3, Lesson 3 for AP Calculus. The title of today's notes, this is graphical analysis still. We are talking about the function relative extremum, where we have function minimums and function maximums. All right, so the setup is already copied down. We are in standard H. What is standard H? We've been on it for now. This is the third lesson. Something about graphs.
I never know what the standards are.
Go back to the unit guide. I just have that 2 pages back for your notebook.
Oh, okay.
I'll be first. Analyzing derivatives.
Analyzing derivatives. Thank you.
I gotta be say it.
All right. So we already talked about what it means to be a critical value. So now I'm going to talk about what it means to be a relative extrema. Yesterday I touched on it a little bit. Now I'm going to be more formal about how I talk about it. So whenever I have the derivative set equal to 0, I get a critical value. That's from yesterday.
Yeah.
And the other critical value occurs where? From yesterday.
DNE.
Where what is DNE?
Oh, F prime.
Whatever point you're looking for.
F prime. So it's F prime equals 0 or F prime DNE. So now we're looking at when F prime is 0, that gives us these relative extrema. So relative, another way of saying relative, oops, that's not good. Relative is local.
Relative equals local.
All right. So when I say local, I mean just within a certain area, not for the entire graph. Because maybe somewhere over here on this graph of f, it sometimes decides, oh, I'm going to turn around way up here, but we don't know that because we can't see the rest of the graph. We can make an assumption that it goes on and on forever this way, but we don't know. Not until they give us perfect information, which is given by an equation. So the perfect information is the equation. Next best thing is a graph, and even worse is just a list of points on a table. All right, so function relative extrema, that's the topic here. So I'm going to say function relative extrema is notated like this, function relative extrema. And this is where I have an f prime change. Okay, I need to go back to writing in blue. So this is where we have an f prime, the derivative sign change. All right. So what does this mean? Someone say this in their own words. I said f prime sign change or derivative sign change. What does that mean to you?
Negative to positive.
What goes negative to positive?
Like the graphs, like
The slope.
F prime is linear. No.
The slope.
Yeah, the slope changes from negative to positive. So if I looked at my graph of f down here, look, I had a slope that was positive, and then all of a sudden the slope changed to negative. This is in our notes yesterday, where we know that we have a minimum if I go from a negative to a positive, and I know if I have a maximum when I go from a positive to a negative. And now I'm making that very explicit, where I say the f relative minimum, this is, how do we annotate this? This is going to be f min. It has a relative minimum when f prime changes from, what is this? Is this from positive to negative or negative to positive? I just went over this. So
Positive to negative.
positive.
Oh wait, min to max.
So I'm talking about a minimum. So look at this minimum down here.
Negative to positive.
Yeah, it's a negative to a positive. So negative into a positive. All right, and then obviously this one is the reverse. So this is f max for our annotation. And this is where f prime changes again. From what to what?
Positive to negative.
Positive to a negative. So be careful here. I'm going to do something on the side over here in green, because I can still have a critical value where there's not a relative extrema. You guys want to see that example? So this example on the side is going to have CV, yes, check, but relative extrema. So relative extrema Extrema, no.
I don't like that word.
Yeah, me either. Makes me
Relative
feel
extreme.
uncomfortable.
Remember when we talked about extreme value theorems? What happened at extreme value theorem? That proved what?
I can't remember.
EVT. A lot of people have been doing flashcards.
Minimum and maximum.
It proves minimum and maximum.
Wait, so I don't. What does the check in the X mean? Like.
Okay,
yes and no, so-
let's change that to instead of a check and an X, we'll say, come on, eraser.
Ah,
I mean, I'm fine with that, but you guys can change it to this. You can say yes and no. A critical value, it has a critical value, but it doesn't have a relative extremum.
And that is for this graph of F. Right?
This is going to be for the graph that I'm about to do right over here. It's just a quick little sketch. I don't even want to do the axis. I'm just going to do a quick sketch.
I'm so confused.
It has a
So that's
positive...
just like a side note going on.
Side note, yeah. Side note, I can have a graph that looks like this. I have a slope of 0. That means I have a what?
A CV.
A CV, a critical value. But I don't have a relative extrema. Why?
Because there's no max in min.
Yeah, there's no max in min. And what about the definition? Look at this definition at the very top.
Never
It's only
goes
going
down.
positive.
Yeah, it never goes down. It never turns to negative to positive. Never goes from positive to negative. There's no sign change. I'm positive, positive, 0, positive, positive. I haven't gone from negative to positive, nor from positive to negative. So this does not have a relative extremum.
Because it's just going up.
Because, yeah, it's positive. You can do like a red line for our derivative. It's positive here and positive here. So it just stays positive. There's no extremum. But there is for this graph. So over here, our derivative in red, we have a slope of 0 here. So f prime is equal to what here?
0.
F prime is equal to 0. What about this left-hand side? What is f prime?
Negative.
F prime is negative. So how do we notate that in symbols? With 0?
Less than 0.
Less than 0. What about over... Wait. Is it negative?
Yes.
It's going
Wait, how
up.
do we?
It's going up.
Yeah, so greater than 0.
It's been a rough day.
Oh gosh,
Oh,
my eraser's
no.
lagging.
Tried to be all fancy and he just erased it.
What the heck? It's still being held down.
Whoa! Why is it doing that? That's so weird. God, Abigail, stop. There's a bird. I see a bird.
All right, let's try this again. F prime is greater than 0. This is positive slope. If I drew a slope here, it happens. I have a positive slope. What about over here? Between
Start crying.
my derivative equal to 0 and this point over here, we'll say that this point right here is x1 and this point is x2. Between x1 and x2, what is the derivative?
Negative.
So f prime is...
You wrote x1, x1.
Oh shoot.
That's what I just said.
It's okay. Everybody makes mistakes.
I didn't mean to.
Thank you, Isabel. Thank you, Carly.
Everybody makes mistakes. Everybody has those days.
F prime is negative here. And then again, right here at x2, I have a slope of
0.
0. F prime is equal to 0. F prime, come on, equal to 0. And then on the right-hand side of the x2, I have what?
This X. Wait, oh.
F prime
Positive.
Greater than 0.
positive, or greater than 0.
I
Perfect.
was trying to say.
So notice what happened. The derivative here was positive, and then it was negative. Positive and negative, that goes with...
Pattern.
Yeah, it goes with maximum. So if I just told you this information and where it happened, you'd be able to tell me, oh, well at x1, there was obviously a relative maximum. Okay, let's look at the graph of f prime. So if
Should we
what
write that down? Or?
I mean, we already wrote it down that when f changes from positive to negative, we know what we have. But if you want to write additional stuff, you can. So what type of function is this? Is this a linear, quadratic? Is it cubic? Is it quartic? Is it polynomial? What is this guy? Exponential maybe?
It's cubic.
Cubic? You guys agree?
Yeah.
Cubic? Is it positive cubic or negative cubic?
Negative.
Well, it goes from positive
Wait, what
to
is
negative,
cubic?
so it's going down, so it's negative.
Cubic means it's something x to the power of 3. this means cubic.
So how did we get
X
that?
cubed. We know it's cubic because it has two changes and it looks like a cubic function from what we remember.
Okay.
It has a hill and a valley. Valley and a hill. Is it a negative cubic or a positive cubic though?
Negative.
So I hear two people say negative. Joy and Rosalie said negative. So treat this as a line. If I straighten it out, if I pull this end and I pull it down, and I pull this end and pull it up to make it a straight line, this would be the slope. Is that a positive slope or a negative slope?
Positive.
So this is a positive cubic. Therefore, the derivative of a positive cubic is a what?
Oh my god.
A linear or an exponential.
3x squared?
3x squared. What is x squared?
Oh,
Linear.
X squared is not linear.
That's exponential.
Oh, it's quotient.
You're getting closer. It's using powerhouse to get there. But what is the name of the function? Here's the shape. Can you draw the function?
Quadratic.
Quadratic. What is?
I knew it started with a Q.
So it's a positive quadratic. What does a positive quadratic look like? Is it a rainbow or a smile?
Smile.
It's a smile. Yeah.
Can we write how we got that? We knew it was positive.
Yeah, can we put that somewhere?
Okay, so we can write it down here. So positive cubic. Positive cubic.
How do we know it's positive? I don't get it.
Because
You draw a line between where it starts and where it ends, and if that line goes up, it's positive.
that's a better way of thinking about it. Yeah,
That
I always think about pulling it taut as if you have loose string and then you straighten it out. But maybe you just want to draw a dot from
Oh, I
here
see.
to a dot to here and then see what the slope
Okay.
is. So do you guys prefer drawing a point from the very beginning and a point to the very end to see if it's positive or negative slope?
Yeah.
Okay, so I'm going to say
Whoa.
Can I close the door?
yes.
Go see if you broke something.
Because the average rate... Okay, my pen is starting to freak out. From start to end,
He did know.
is positive. So this is a positive cubic because the average rate from start to end is a plus. You can maybe do it in a circle so you don't think of it as a T. And cubic, you just have to remember that whenever you have a double wave, it's usually cubic. A hill and a valley.
Then how do you know if it goes up and down? Like again?
Yeah, that's a good point. So we assume it's cubic. We don't know for sure. I agree. But from the limited knowledge we have, we can say it's cubic. Maybe this is only part of a sine wave. I don't even know. It could be trigonomic or trigonometric. All right, so this is a graph of f prime. So where is our max and min? Again, use the same information. Come on, girls. We only have a limited amount of time today. Max and min.
Limited.
The
The zeros. Where it crosses the x-axis.
These are, yeah, from yesterday. Those are our critical values.
And down.
So I went from positive to negative here of f prime. F prime, the height was positive, and now the height is negative. So what is this thing right here? Is that a maximum or a minimum?
that's wait, it was positive and then it went to negative?
So look, the height up here is positive, the height down here is negative. It went from positive to negative.
So it's maximum.
So that's a max there.
Wait, but how can we switch from doing slope to doing heights?
Good question. Someone else answer that.
We went to a different graph.
Oh, it's a graph of f prime.
Yeah.
Okay.
Yeah, baby.
Okay, so what about here? Here we have another critical value. Why is this a critical value?
Zero. So you're
Because what is zero?
You're looking at all the
F prime.
Ah, there it is. F prime, or the height is 0. Both of them are correct. So it's a critical value. That means we have a max or a min if what?
Sorry, I'm ready.
If f prime is 0.
No, because
Or if the sign changes.
yeah.
Goes from
Can I give you another example where it's not 0? So if this was f. Let's look at a graph of f prime really quick on the side. Let's say I had a quick graph like this and I went like this. So I touch once. Did I go from positive to negative?
No, you went to positive to 0.
I went positive to 0, back to positive. I didn't have a sign change. I didn't go from positive to negative.
So technically you just stayed
Positive to negative to positive.
This one didn't have. Oh wait,
Negative.
this one never went negative, so there's no sign change. This one has no relative extremum.
So
the
then the one
graph
over
of
here.
F does, right?
This one does, because this one goes from negative to positive or from positive to negative. So what is this one? If it goes from negative to positive, this is a
Minimum.
minimum.
Wait, I don't get why there's a 2 on the graph. Like I thought it was either
Where?
like how there's like max and then min. So like those are both the CVs.
The critical value.
So you have to find all the critical values and then determine whether they're
That's what
minimum
you're
or
analyzing.
maximum. So how did you know that the left one was max and the min?
Because it goes from negative to positive,
See up
going
there
down.
when it goes negative to positive, it was min.
Or
Positive to negative was min.
Oh, okay, I get it.
Anyway. You're always like,
What?
oh.
It's just because like I love it that moment when like you like really understand it, you know?
All right, so where were our? Let's label these. I'm kind of running out of room, but I just want to use this one slide and we can be done.
I was like, oh, that's cool.
So the F relative extremum.
A little more than I thought you were going to say.
Extremum.
Oh, cool.
Where were they? What x values were the extremum?
0.
for both graphs.
That's fine.
For both graphs. This one would have been x1. This one would have been x2.
So x1.
They probably did this because I think that they're goals.
x1.
Yeah, no one.
Sorry, I did a comma there. I should have done x1,
No, I
comma,
think it's
x2.
and then it's-
What about the relative minimum?
Like this is just doing it.
X2.
That's a x2. And the f, the function relative maximum, is where?
Isn't this just
X1.
No, his mom,
Exactly.
Mary.
so, Mr. Swindell, do you only have to do that for the second graph? Because it's way easier to do that on the second graph than the first graph.
On the AP test, they will give you both of them. They'll give you
So
f
you
and
have
f
to look
prime.
at, okay, so you're gonna be like, okay, x1, it's 0, but it's going from negative to positive. No, it's not. On the first graph,
First graph, it went from a positive slope to a negative slope.
so that's maximum.
Exactly.
Okay.
To a negative slope.
Ooh. Wait, so this is for the first graph up there?
This is for
For
both graphs. I can give you either this one or this one, and you can tell me this information. I gave you both so that we can be familiar with both. So, in order to find maximum and minimum, what do we have to look for first? What gives you a hint that there might be a max or minimum?
CVs.
CVs. And where do CVs happen?
0 and D and E.
0 for what?
F prime.
F prime. So once we see, you first look for F prime equal to 0 because that will indicate that we have a CV and therefore we can possibly have a maximum or a minimum. So the first step should have been, where is F prime equals 0? That's why we looked at F prime equals 0 first. F prime equals 0 on this graph just means what?
Did the slope is 0?
No, not the slope of this one because this is now the graph of F prime.
The height.
The height.
The height is 0.
Yeah.
Digest. 10 seconds.
Wait, so steps. You find the CV. Then once you find the CV, determine what the CV, if they're minimum or maximum.
So find the CV and see if there's a sign change. And then if
you
there
write
is a
that
sign
down?
change, yeah, I'll write it on the next slide. So if there is a sign change, then go to the next step. So we'll write down our steps here really quickly. Step 1.
Wait, how much more notes do we have?
I was going to be done, but I'll write down these steps for us.
Okay.
Yeah.
Look for F prime equal to 0. Step 2. If sign change, that implies what?
Maximum.
There's a maximum or there's a minimum. And then step 3, if F prime goes from positive to negative, that means what?
It's max.
Positive to negative, that's a max. And if f prime goes from negative to positive, that implies the other, minimum. Those are the 3 steps over and over for determining extremum. This applies for both the graph of f and f prime depending on how you interpret it. F prime will either be the slope on this graph or the height on this graph. So you have to be careful. That's why we did our first lesson, 3-1, was analyzing the difference between height and slope depending on what graph you're looking at. All right. That concludes the notes.
Goodbye.
Say goodbye, everyone.
Love you.
Love you.
I hate Abigail.